Alrighty, alrighty, folks. What are we learning today is the question. We are learning about functions, I believe. So I am just trying to function. That is all I'm trying to do. I'm just trying to function. This had me so messed up. This had me so messed up. So earlier, my computer said it was like 11:30 in the afternoon or something, and I was like, where? What? Like what? No. What happened to the whole day? And then I realized my clock was all wrong. But anyway, so functions allow us to do things with variables and computational power. So we're going to learn a little bit about that in today's episode on learning backend engineering. Let's dive in. So functions allow us to reuse and organize code. For example, say we've written some code that calculates the area of a circle. We have the radius, which is equal to 5, or assigned to the number 5. Area is assigned to pi times radius, pi r squared. Fun. So this works great. We can calculate the radius of any circle. Awesome. So you could rewrite it like this. This is how they say you could do it. But the smarter way to do it is to define a function, and you just pass in a parameter called r for radius, and then you just return pi r squared, and then you just calculate by passing in the radius to this function. So this is awesome. This will come out pretty great. Okay, so we can kind of ignore all this. I'm picking up the gist of it all from guys. Sorry, I have allergies. I don't know if it's the allergy season or what, but it is tearing me up. It's been like 2 weeks, maybe even more, 3 weeks of just not feeling spick and span, you know. Okay, so let's see. We need to build this function, I imagine, is what they're going to have. So we need to calculate the size of a weapon's attack area with a 1.0 meter sword. For example, a player can attack in the area of 3.14, so pi square meters around them. You can use this area of a circle function to do that calculation. Fix the bug on line 14 and 15. Okay, so we have this, line 14 and 15. The axe area and spear area variables should be set to the correct value instead of 0. Okay, so don't touch above this line, don't touch below this line. It looks like we are going to steal this. Boom, right? So, axe area. Where does it give us the axe area? Oh, this is already defined. Okay, cool. So I will say, boom. So we'll invoke the function. So we'll pull down the function from here, and we'll pass in the axe length. And then we'll try it one more time. Let's see if this is heading down the right direction, and we'll pass in the spear length. So basically what it's doing is passing this 0.5 into this function, and this function will receive 0.5 up here. This is where the function is defined. Kind of ignore all the other code. Guess I'll even zoom in a bit for y'all. So this function is passed in 0.5. 0.5 comes into here. We've defined a variable that's just 3.14 for pi. And we're returning the area, which is going to be 3.14 times that 0.5 times that 0.5. And that will return the proper length. So looks like we'll be able to unpack some more of these today. Become a pro member? Uh-oh, folks. Uh-oh. Okay. I might have to pause the feed. Looks like I need to become a pro member. Hold on. Give me a sec. All right, we're back. I'm back. Had to become a pro member real quick. Okay, so boom, let's submit the code. Looks like we tried. Oh, okay, reset everything. So we'll invoke that function one more time, and I need to pass in the axe length and area of a circle and spear length for this area of the circle. Let's try. Nice. All right, we're functioning. We're functioning, and that's when I lost it. A midnight in Austin. What the heck's this for? It's a great song, by the way. Okay, so functions have multiple parameters that you could pass in. They're just fancy names for inputs. For example, the subtract function can accept two parameters, a and b, represented as number 1, number 2, or two numbers represented by a and b. Naming the parameters does not matter as much. We can name them anything we want. It's just relevant to us naming them, so we understand how to define the function. This is where logic and programming gets a little bit interesting. So naming the parameters doesn't matter as much as setting their order. The first parameter is the first one that you passed in. The second parameter is the second one you passed in, and so on and so forth. So this value 5, 3, A will be equal to 5 or assigned to 5, and B will be assigned to 3. Print the result. Boom. Okay, cool. So we've understood a little bit of what's going on. Let me try to do this. So we need to calculate the total damage for the number of enemies using the 3 different parameters. Okay, so complete the calculate damage function that takes 3 numbers as its parameters and returns a result of adding them all together. Interesting. Okay, so what we could do is easily just say return opening attack plus core damage plus finishing move. And that should do what we want to do. And I want to, I guess before doing it, let's run it. Boom, 14 damage. Sweet. So I want to just take a moment to explain. We can see if we're right, actually. Submit. Sweet. So I want to take a moment to kind of explain this a little bit more. So if we define a function, we can name a function anything in the world. So I could type it anything I want, right? But the function name is just going to be relative to what the function does. So let's say we're building a function. I thought really hard about it. I want this function to add 2 numbers. So I'll say add numbers for the function or something. Add even, you could just do add, but maybe you can even be very verbose and say add 2 numbers. You can name the function whatever you want. And here we can get number 1 and number 2. Now these 2 parameters, you can spell them out. Number 1, you could spell them out number 2 like this. You could be very verbose. You could say in1, in2 if you wanted. This is just how you're going to describe the numbers being passed in. You can even spell it like first number, right? Just something that's relevant to your function, right? Whatever you want to do. So in1, in2 will work fine. And basically we could say return in1 plus in2. And what this will do, if we run this function now, so I'll print it here, add 2 numbers, and I'll pass in a number. So I'm printing the function so I can see what happens. But here I can inside the print statement call my function and then pass in 2 numbers. So I'll pass in the first value, which goes to n1, and the second value, which goes to n2. And obviously at addition, that's not a huge deal, but we should see, boom, 3. And there's our print function working right there. So that's us right there. And I can also describe it by putting a comment saying here is, and putting a string next to the comment, or putting a string as the comment. Here is my add function. I'll just represent it by saying func. And I do this all the time in console logs on the web development side, but I just wanted to show you guys how functions kind of work, right? So if we wanted subtraction, right, maybe we change this to subtract 2 numbers, right? And you also don't have to change the name, for instance. If I wanted to keep the name as add 2 numbers, I could. It's just obviously deceptive to what it does. So the only reason why we really name functions is so us humans can understand it. And I think that's a really important teaching point. So this will still work. It'll subtract the numbers, right? So 1 minus 2 equals -1. So, and then obviously if I flip the order, if I do 2, 1, we'll get a different answer because 2 minus 1 is now what's going on, which is 1. So the teaching point here is just we can name functions whatever we want. It's just relevant for us. And then also the important part is the parameters being passed in. It looks like we can add in 3 if we wanted, in 4 if we wanted. But then our function, whenever we call it, we also have to add an extra number. So otherwise, we break the code because these are required parameters, I imagine, unless type safety is not a thing in Python, which it may not be. So boom, if we do all of that, we should get the sum of all that, which I have no idea it is, -8. Boom, look at that. So yeah, so that's a little bit about functions. Let's keep going. I'm not the know-all kind of guy, but just wanted to make a teaching point. I know when I was learning code, I didn't really understand how functions worked for quite some time. Okay, so where to declare functions? You've probably noticed that a variable needs to be declared before it's used. For example, the following does not work. My name does not work because my name is under where it's being used, unless we hoist, but that's a whole other conversation. I wonder if can you hoist in Python is the question. This is just a personal side note that I'm curious about. Which languages? Okay, cool. So hoisting is actually defining a function under. So boom, right here. Here's actually hoisting. So main is defined under where it's being called. But okay, so let's see. So but variables have to be declared first, and then if they're used, then they're used after. You can't use them, then declare them. So you have to say what the variable is, and then boom, print it out or use it or whatever. So, okay. So assignment, there is an issue in our bug, fix it. Oh, is this actually the issue that you can't use main until that was the issue? So I guess you can't hoist in Python. That's interesting, but it just said we did on the internet, or we could. So in JavaScript, you can actually declare a function and then you use it above. It's weird. It can run the thread asynchronously in that situation. But okay, so order of functions. All functions must be defined before they're used. You might think this would make structuring Python code hard because of the order. Because of the order of the functions needs to be just right. As it turns, there's a simple trick to make it super easy. Most Python developers solve this problem by defining all functions in the program first, then calling the entry point function last. Conventionally, this entry point function is called usually main. This is a pattern. Okay, so this is where, oh, I see. Okay, so technically this person is hoisting the functions, but the first function where the entry point happens so I guess this is hoisting to some degree, if that would work. So function 2 is clearly defined below where it's being called, but because main is being called at the very bottom, it works. Order of functions. All functions must be defined before they're used. You might think this would make structuring Python code, oh, the same deal. Okay, so Python functions must be defined in order to call one another. True. False. Oops. Python functions must be defined in the order they call one another. Oh, I see. So it's asking about this part now. Interesting. So the entry point function must be called main. No. Just a consistent naming convention, it seems. Functions. Guys, we're level 7. Ooh. Well, golly. Functions, practice, degrees, conversion, formula, Celsius degrees, boom. Assignment. In this fantasy quest, as characters are running around the map, they may lose health due to heat exhaustion. The game tracks the temperature in Fahrenheit, but we also need to display the temperature in Celsius for the outside players of the US. Write a function called toCelsius that returns the thing to Fahrenheit. So how to calculate, we will steal this logic, and we will say return, boom. And we just need to replace F with this. We either need to replace Fahrenheit, and I'll give a little space in here. I like my functions like that. So we could either describe it as F, or we can call it Fahrenheit. I will go ahead and put Fahrenheit because I like to do that instead for the variable. I wonder if this will break the code because it's declared as F down here. I know in JavaScript, you can actually rename variables from where they're being passed in. Oh, sweet. Okay, so you can do the same thing in Python. Makes sense. Makes perfect sense. Python and JavaScript are very, very similar. So, okay, so functions quiz. Reference the example functions and answer the questions. Which keyword is used to create functions in Python? Define. Sweet. Which is not an alternative term for values that are passed into a functions? Slots. Never heard of that before. It's always parameters, arguments, params, and args. A function must be defined to be called many times. Defined once to be called, I think once. Yeah. All right. We did okay on the quiz. That's awesome. Let's see where we're at. Oh, we got more work to do, folks. We got more work to do. Hours to seconds. Assignment. We need to be able to display the current time to our players. The problem is that that time is stored as a number of hours, but we want to display it as a number of seconds. So we need a function hours to seconds. Okay, so we could say return hours. Let's see. So there's 60 minutes. So times 60, right? Because there's 60 minutes in an hour, and there's 60 seconds in a minute. So I think that'll do it. Yeah, roughly. Sweet. None. Return. And guys, there's definitely other ways to cut the pie too. Typically in software, there's 50 ways you can do something. So this doesn't have to be 60 times 60. This could actually be times 3600. That would work too. 60 times 60 is 3600. You could even do 60 times 60 plus 1 minus 1, right? You could add a whole bunch of random logic. And that's the tricky part of programming is there's 15 ways to do the same thing. So the point I'm trying to write here is or highlight here is in software, because of the freedom that you can append more logic if you want to the same answer or do multiple ways to do the same answer. This should all return still a positive thing. Because of that, there's this idea of clean code. There's this idea of like being creative with your code. There's this idea of being more robust with your code. But the point is like there's also opportunities where you can make your code way worse, doing extra logical steps that maybe there's a better way to do something. So these are obviously smaller functions, but when you start getting bigger functions that call other functions and do other stuff, it's very easy to append logic that takes you in loops or like, or logic that could be cut through. So I think that's important to highlight too, is that engineering as a whole is usually in my opinion, the least logic wins. Like the most straightforward answer with like the least amount of moving parts is usually going to be the best one. Usually, put an asterisk there. I wouldn't say all the time, but I would say most of the time. None return. Okay, when no return value is specified in a function, for example, maybe it's a function that prints some text to the console but doesn't explicitly return a value. It will automatically return none. The following code snippets all return the same value or none. Okay, so what happens if there is no return function? It is a void function. Looks like it returns none. Multiple return values. In Python, we can return more than one value from a function. Sweet. First, we can do it by this. All right, so I imagine it's going to say, have us return. The assignment is return boom, boom, boom. So we will return first name plus a space. Oh, I think it'd actually be like this in Python, maybe. Let's see. Plus a space and the warrior. Let's see if that works. Let's run that. Nope. Line 15. Let's try our pluses. Let's try the pluses. Line 15. What the heck? Oh, and we need to do power at some point too. So I'll just put it in for right now. Frodo Baggins. Sweet. After adding 1 to it, do we need to add 1? This? Okay, cool. Well, easy peasy. Are the values passed into a function by the caller? Let's read about this. I actually don't know if parameters, I believe arguments are being passed in, but let's see. And parameters are the things being pulled from the function, but I don't realize they're actually different, to be honest. Parameters are the names used for the inputs when defining a function. Arguments are the name of the inputs supplied when the function is called. Okay, cool. So that's our answer right there. Arguments are the values being passed into the function. The function pulls the parameters, not the arguments. They're, in my brain, still the same thing. Okay, so parameters are going to be this answer. Parameters are the inputs specified by the function's definition. So for constructing a function, here's our function. Anything we pull into the function is a parameter. Pull is parameter, I guess, is a good way to think of it. Pull into the function parameters. I guess arguments would be the other ones. So default values for function arguments. Python has a way to specify a default value for function arguments. This can be convenient if a function has arguments that are essentially optional, and you as the function creator want to use a specific default value in case the caller does not provide one. Okay, so we assign it with the equals operator in case someone doesn't pass in part of that function. Perfect. So we could default armor to 0, just like that is what they're saying. So if no one passes in an armor point when they pass in the get punched or whenever they call the get punched function or the get slashed function, we default it to 0. And let's see, do we need to return something? So assignment, complete both get punched and get slashed functions. They should take 2 arguments, health and armor. Change the function so if no armor argument is passed, it defaults to 0. Each attack does different damage. Getting punched takes 50 damage, return slash does 100 damage, but the armor should absorb the attack by subtracting from the damage. The rest of the damage should be applied to the health. Return in a single. Okay, so we'll do a little bit of logic here, I think. So we need to return health minus armor, we'll say damage. But wait, we're not past damage, are we? So 1 slash, oh, here we are. We're slashed 50. We'll say damage after armor. How about that? And we'll define this variable by saying damage after armor equals 50 minus armor. Or I guess it should be armor subtracted by 50, really. But either or. So boom. I think that'll work. And then we need to do the same thing here. Is this, but instead of it being 100, one of them's 50, the other one's 100. So getting punched is 50 damage, getting slashed is 100 damage. So that should work. I think, let's see. Submit. Nope, we're wrong somewhere. Okay, so armor. I thought that's correct, to be honest. Each attack does different. Let's reread it one more time. So each attack does a different amount of damage. So let's define the damage. Getting punched does 50 damage. Okay. And getting slashed does 100 damage. So damage equals 100. The armor should absorb some of the attack by subtracting from the damage. Okay, so armor minus damage is what we want. Or I should say damage subtracted by armor, I believe. Looks like we could just redeclare damage like this. And then health minus damage. How about that? Let's try that, right? We'll copy this down and see if this will get us through, huh? All right, so health minus damage. We got some different numbers. Nice, nice. Little logic. We needed to reread some stuff. Perfect. Okay, so that works here. We could also streamline this a bit. This is where code has 50 different outcomes. We could do 50 minus this. It's just a placeholder here, and that should still work. Let's test. It does. And we could also do this. Put it parentheses and just really streamline our code if we wanted. Now, I would probably honestly keep it this way. This seems like a pretty robust way, but not a problem here either. This should still work. Let's try. Sweet. So that's kind of the point. Is there's always 15 different ways to cut the pie. Okay, so printing versus returning. Some new developers get hung up on the print and return. Print is just something for the terminal. Return is actually computing typically. So is a function that values something in the or prints something in the console. It just shows us what's going on. Return is actually executing the computational power, right? The function stuff. So yeah, let's see the assignment. So there is a problem in the get title function. It's supposed to calculate the title. So we're supposed to return the title, not print it. And again, we can show that there's 50 ways to do something. So we could actually just return right here, and that should still work. Perfect. Curse. An enemy's weapon can be used or can be cursed so they don't deal as much damage. Complete the curse function. It accepts a weapon damage and returns two values. The lesser cursed damage, 50% of the weapon, and the greater cursed damage, 25% of the weapon. Ooh. Okay, so let's see how do they do this though? You can multiply. How do we know which curse though? Float lesser cursed. Curse equals damage weapon. What do we got going on here? What do we got? Okay, I'm gonna return the weapon damage real quick. Let's see what it is initially. All right, a little stumped, guys. A little stumped. Here we go. So you can multiply a number by a decimal to get the percentage of the number. For example, I get that part, but how do we know which one's lesser cursed and how do we know which one's more cursed? Return. Shouldn't we need need more arguments, right? Do we assign it? Here we go, just like this, right? Is this what we're supposed to do? Or we default the values of these? File, most recent call stack. Guys, I am a little bit stumped on this one. All right, so let's see. So enemy complete the curse function. It accepts a weapon damage parameter and returns two values. Oh, I see. Okay, so we need to make it return. We need to make it return weapon damage times 0.5 and then weapon damage times 0.25, right? Nice. Okay, there we go. Had tongue-tied, folks. Had me all worked up there. We're on the last one. We're in chapter 3, the last, folks, and we're level 8. I didn't even realize. Golly. Okay, so enchanted attack. In Fantasy Quest, a weapon can be enchanted to do bonus damage. Complete the enchanted attack function. It creates a new enchanted name for a weapon and calculates how much damage the enchanted weapon will deal to a victim. It accepts all three parameters: player health, damage, weapon. Okay. It should do of the following things in the function body. Calculate and store the enchanted damage in a new variable. The enchanted damage should be the input damage plus 10. Okay, so we'll build that real quick. I'll say enchanted damage equals damage plus 10. Okay, calculate the calculate the new health in a new variable. The new health should be the input player health minus the enchanted damage. So we'll say equals player health minus enchanted damage. Sweet. Create a variable called enchanted weapon. It should be the input weapon with the string enchanted added to it. So we should say plus enchanted space. Okay, cool. Return the enchanted weapon and the new health in order. So then we should return new health plus, had it backwards. So enchanted weapon plus new health. Or maybe they want it like this, comma new health. One of the two. Let's submit. Let's see. See if we done it. Ooh, first take drink in the building. Guys, that's chapter 3. We learned a little bit about functions. I'm excited for the next chapter. I'll wrap it up here. Let's overlook where we're at. Guys, we grew a bit. We grew a little. We learned about Python functions, a little bit about the hoisting deal, what you can't do and can do. That was a good series, and we're level 8. We're level 8 now. So we're cruising right along. 51 problems solved. Pretty exciting. Pretty exciting. So I will wrap it up here. I will see you on the next episode.